Planning involves making decisions about future activities and events. For manufacturing activities, such decisions may relate to the coming days or the coming hours, or decisions may concern activities and events which are 6 months or more in the future. In the short term, for example, this might be when a new manufacturing order will start in production, or in the long term, when decisions are made to hire more staff or invest in new machines. If we look at the planning hierarchy, we can see that we have two sections. The one on the left side with material planning, and the one on the right side with capacity planning. In this section, we will focus on the capacity side. From the sales and operations planning, we will get the production plan. And here we normally talk about products group or product families. Once the preliminary production plan is established, it must be compared to the existing resources of the company. This step is called resource planning. Two questions must be answered. Are the resources available to meet the production plan? If not, how will the difference be reconciled? A tool often used is the resource bill. This shows the quantity of critical resources needed to make one average unit of the product group. For instance, suppose the labor normally available in a period is 1,200 hours. The priority plan requires 1,400 hours, which is a difference of 200 hours, or about 17%. Extra capacity must be found, or we need to adjust the priority plan. On the next level, the master planning level, we have the master production schedule, which defines the required quantity per period for each finished product. The bucket is usually a week, and the time horizons up to 3 to 6 months, or at least twice the longest production lead time. The master production schedule is then checked with a rough cut capacity plan, which checks whether critical resources are available to support the preliminary master production schedules. Critical resources include bottleneck operations, labor, and critical materials. The next level is order planning. On the material side, we have, for example, the material requirements planning, where we use the master production schedule as input, and together with the bill of material, MRP derives demand for components, subassemblies, materials. The material requirements plan's objective is to determine what components are needed to meet the master production schedule and, based on lead time, to calculate the time when the component must be available. Capacity requirements planning are used to verify that you have sufficient capacity available to meet the capacity requirements for your MRP plans. In this way, you can identify short-term discrepancies between required and available capacity. CRP typically verifies capacity for all the resources required to meet your material plan. The various capacity plans relate only to their level in the priority plan, not to subsequent capacity planning levels. After the plans are completed, production activity control and purchasing must be authorized to process or implement shop orders and purchase orders. The theoretical maximum capacity of a production group is the capacity that could be achieved if production continued around the clock every day of the year. But this is normally not the case, so this capacity figure is rarely of interest. Instead, the calculation of available capacity is based on what capacity can normally be used. This so-called nominal capacity is often stated in the form of 4 variables: the number of machines or other production units in the group, the number of shifts per day, and the number of hours per shift, and also the number of working days in each planning period. The nominal capacity can be calculated from these variables. In general, the nominal capacity cannot be fully utilized, and an estimation of the available capacity must take into account different forms of capacity drops. For example, there may be drops in capacity as a result of machine breakdown, short-term absence, maintenance activities, and so on. After deducting such capacity drops, we can then talk about remaining gross capacity. However, various types of indirect but unavoidable downtime must also be taken into account, during which no direct production can take place. It may be waiting time for materials, time for reviews with supervisors, small breaks in work. Capacity may also be required for non-planned manufacturing, such as repairs after items have been rejected or urgent orders of different sorts. After having adjusted the nominal capacity by such factors, we arrive at something called net capacity, which represents the capacity estimated to be at the company's disposal to carry out planned production activities. To be able to calculate the capacity requirements, quantities in production plans and master production schedules must be translated into the capacity requirements. And for manufacturing a product, this is generally retrieved from operations times which are stored in the ERP system's database. Capacity is the capability of a worker, machine, work center, plant, or organization to produce output per period, while load is the amount of planned work scheduled. We can see the workshop organized as a controller of input and output. New order arrives and are planned but not released. Instead, they are in a queue for release. The workshop organizer can then control the load by comparing the output and input. By keeping input at the same rate as the output, the load will remain the same. Capacity requirements must always be compared with available capacity. If there is discrepancies between available capacity and capacity requirements, there are in principle 4 different ways of achieving conformity. We can increase or decrease accessibility to capacity. This can, for example, be done in short term by working overtime or using subcontracting. In the long run, by hire or lay off personnel, adding or selling machines, or adding a number of shifts, but also by subcontracting. Another alternative can be to reallocate current capacity between different departments and production groups. A third option can be to decrease the requirements for capacity. That means changing the load, for example, changing the order quantity, smaller order, smaller load. And the last option is to reallocate the requirement for capacity between different time periods. That means moving loads between time periods. There are 2 main approaches to the allocation of tasks to work centers: the finite and infinite loading. Infinite loading does not consider the existence of other shop orders competing for capacity at these work centers. It assumes infinite capacity will be available. Notice the over and underload. In this case, the load pictures give the planner a realistic picture of what load the planned order will give us. By then, using the 4 principles presented earlier, the planner can change load so it can be met by the available capacity. The other option is that we use finite loading, where we assume there is a defined limit to available capacity at any workstation from the beginning. If there is not enough capacity available at a workstation because of other shop orders, the order has to be scheduled in a different time period. The load is smoothed so there is no overload condition. Most ERP systems and companies use the infinite loading principle and manually tries to achieve conformity by using priority rules and the 4 principal ways of changing the capacity and load.